Hey, this is our physics video, and we're going to be talking about internal energy,
thermal capacity,
and then...
specific heat capacity.
Okay, enjoy.
When we look more detail of an object, there are two types of energy inside an object. The molecule of an object has its own motion that contains kinetic energy. The force between molecule and object also contains an energy called potential energy. Every object has different potential energy depending on the object appearance, such as the object particular state. It can be solid, liquid, or gas. The object has also kinetic energy based on its temperature. Temperature regarded as a measure of kinetic energy per molecule associated with the thermal motion. The higher temperature of an object has, the faster molecules are vibrating, which means that the higher kinetic energy will be. To get an internal energy of an object, just add the total potential energy with its total kinetic energy.
The thermal or heat capacity of a particular body is the energy required to raise the temperature of that body by 1 degree Celsius. The equation of this is C equals delta Q over delta T. The delta Q is the change in thermal energy, delta T is the change in temperature, and C is the thermal capacity. An example problem is if we take a beaker of water of 100 milliliters and heat it so that the temperature increases from 24 degrees to 60 degrees and about 15,000 joules of thermal energy is transferred, what is the thermal capacity? We can solve this equation by simply substituting in the values and solving. So the answer is about 417 joules per degree Celsius.
To demonstrate the concept of specific heat capacity, let's imagine a bar of silver of 1 kilogram in mass and a glass of liquid water with a mass of 1 kilogram. Now, if each of the items were to be applied the same amount of energy, let's say 1,000 joules of thermal energy, and if the time that these two items were to be subjected to the heat were the same amount of time taken were the same, then by the end of that time period, the bar of silver would have a much higher temperature. Expressed mathematically, if we were to take the change in temperature divided by the amount of energy by the specific heat capacity of silver, we are able to deduct that the change in temperature is 4.3 degrees Celsius. And if we were to do the same thing for water, taking the amount of thermal energy, dividing it by the specific heat capacity of liquid water, then we were able to do that the change in temperature is 0.238 degrees Celsius. Therefore, the change in temperature of silver is much higher because it has a lower specific heat capacity. Thanks for watching.